You hear a lot of big numbers thrown around in the tech world, but this time NVIDIA's $20 billion move is making waves across the AI industry. NVIDIA is acquiring Groq, a small but highly specialized chip company. But who is Groq? What do they do? What makes Groq so valuable to the biggest player in the game? To get to the bottom of that price tag, we have to start with the basics. We need to understand who these folks are and what they have actually built. So let's meet Groq and their secret weapon, the LPU. Groq was founded back in 2016, and right away you see something interesting. The CEO, Jonathan Ross, was one of the minds behind Google's original TPU team. After leaving Google, they built a product called the Language Processing Unit, or LPU, but it actually started out as the Tensor Streaming Processor, or TSP. The name change to LPU was honestly a smart marketing move. When large language models became the hot new thing, they leaned right in, making crystal clear what the chip is for, running AI language tasks at absolutely insane speed. Their journey has been quick. Founded in 2016, first chip by 2019, now they are a name you have to know when you talk about high-speed inference engines. What makes Groq so special? I mean, really, what's the big deal? Well, it all boils down one thing, an absolute uncompromising obsession with speed. We are talking the fastest token per second numbers out there, but specifically for what's called single user inference. Think it of like this. It's not about handling a million users at once. It's about giving an answer from the AI like right now. It's the AI equivalent of a dragster, a super fast car that goes from zero to insane speed, just pure state line acceleration. It's all instant answers in a single digit milliseconds, and this is just not a marketing hype. This incredible speed comes from a really radical design choice. A gamble, some might say that sets them completely apart from pretty much everyone else in the market. On one side, you have basically every conventional AI chip like the ones from NVIDIA. They all rely on external memory like the HBM, high bandwidth memory, or DDR, double data rate memory to hold the AI model. Kind of like having a huge warehouse of data next to your factory. But Groq, no. They decided to put all the memory right on the factory floor on the chip itself. They use SRAM, static random access memory. On-chip SRAM is super fast, volatile memory built directly onto the same silicon die as the processor, CPU, GPU, or microcontroller for extremely quick data access. This eliminates delays from external data fetching. On-chip Groq, data and compute stay on the chip using SRAM, giving ultra-low latency, massive bandwidth, 80 terabits per second, and lower power because there is no need to access external memory. But in case of hop-chip, traditional relies on external DRAM like HBM or GDDR, which offers huge capacity but adds latency, consumes more power. A single Groq chip contains 230 MB of SRAM memory. This is a microscopic compared to the 80 GB of an NVIDIA H100. Large language model sizes in gigabytes to terabytes. If you look at ChatGPT 5.1, Gemini 3.1, a model size are estimated around 1.5 to 2 terabytes. So how this massive AI models will run in just 230 MB of RAM. The 230 on-chip SRAM is tiny and ultra fast, but is smaller than a full AI model. But if you think of like a Formula One fuel tank, the secret is just like F1 car's fuel tank is efficiently filled in during the race. The same way SRAM is also continuously popped up from larger memories, so the AI never runs out of fuel. How the Groq handle models? It doesn't load the whole AI model at once. Instead, the giant model gets broken up into the small manageable chunks. One chunk at a time is streamed onto the chip where that super fast SRAM acts as the perfect internal buffer. The compute unit processes that chunk in a flash, and then the next chunk is already there waiting. It's this continuously perfectly timed predictable flow of data. In the linear scaling, more chips give you a proportional boost in power. Secondly, as we just saw, you get consistent speed performance because there are no compute stalls. And finally, the whole thing is incredibly energy efficient. Let's talk about the scaling for a second because it's a huge deal. When you are working with a really massive model, you can just split the job across a bunch of chips. And because there are no memory bottlenecks, to slow things down. If you double the number of chips, you double the performance. As simple as that. The kind of predictable linear scaling is basically the holy grail in high performance computing. So let's recap. We have a chip that's an absolute speed machine on one hand, but a memory starved monster on the other. Which brings us right back to the $20 billion question. What is the strategic value here? Why would NVIDIA, the company that dominates the market with a totally different design philosophy, be willing to pay so much for this tech on this team? Okay, here is the breakdown. NVIDIA is not just buying a chip, they are buying a unique speed first architecture. It is this wild 144 way, which is a very long instruction word. In short form, it's a VLIW design, which is a super technical way of saying the processor can do 144 simple things at the exact same time. It's insane. They are also acquiring the world class talent that built it, buying a dominant position in the ultra low latency market. And here is the kicker, the chips are made using a process that's cheap and easy to scale. It's a strategic move to own the entire spectrum of AI hardware. The Groq story is more than just a tale of a clever chip design and a massive payday. It's really a preview of fundamental debate that's going to define the entire future of artificial intelligence. So that leaves us with this. What's the future of AI really going to look like? Is it going to be the brute force of massive all-in-one chips, or it's going to be the surgical precision of hyper specialized speedsters like Groq? That's right, there is the $20 billion question, and trust me, the answer is going to shape the future of technology as we know it.